Hello! In this video, we're going to derive the equation for the range of a projectile. So in this diagram, we have a person kicking a ball into the air. And we'll say that when the ball is kicked into the air, the ball is kicked at an initial speed, v0, a launch angle theta, and when the ball is kicked into the air, the ball travels this path. Of course, we have the acceleration due to gravity pointing downward at 9.81 meters per second squared. The whole goal is to figure out what r is in terms of these three quantities. Now, since this is a projectile motion problem, it might be nice if we break up the velocity vector into its components. So the horizontal component would be right here. I'll call it Vx0, and the vertical component is right here. Right, we'll call the vertical component Vy0. Right, so really, we're going to be analyzing the horizontal motion of the ball and the vertical motion of the ball. Now, when it comes to the horizontal motion of the ball, the thing to remember here is we have constant velocity in the horizontal direction. And when it comes to the vertical motion of the ball, we have constant acceleration in the vertical direction. And if you recall, the reason why that happens is because we only have one factor contributing to the acceleration, and that is the acceleration due to gravity. And so because the acceleration due to gravity is pointing strictly downward, no part of the acceleration is pointing the horizontal direction. So we have no acceleration in the horizontal direction, which is why we have constant velocity. Okay, so now let's first analyze the horizontal motion of the ball. Since we are dealing with constant velocity, the equation we can use is horizontal displacement is equal to horizontal velocity times time. In this case, we're interested in the displacement of the ball from here to here. Now, going from here to here, the displacement of the ball is r. The horizontal velocity of the ball is constant. So the horizontal velocity of the ball must be equal to the initial horizontal velocity of the ball. So we can replace Vx with Vx0, and t is just the time it takes for the ball to go from here to here, right? So I'll just call that t for now. Now, if we use trigonometry, we can solve for Vx0 in terms of V0 and theta. We have Vx0 equal to V0 cosine theta. And so this is what we get. So now let's analyze the vertical motion of the ball. Since we have constant acceleration in the vertical direction, we can use one of the kinematics equations for the vertical motion. And the kinematics equation that we're going to use is the following. We're going to use this one. Now, we're interested in the vertical displacement of the ball from here to here. And actually, the height of the ball doesn't change going from here to here. The vertical displacement is just 0. So we have 0, and then the initial vertical velocity of the ball is just Vy0, right? And if we use trigonometry, we have Vy0 equal to V0 sine theta. And then what do we get over here? Now, Ay is just the vertical acceleration. And in this case, the acceleration is the acceleration due to gravity. And actually, since the acceleration is pointing downward, that tells us that the acceleration is negative. So actually, the vertical acceleration is going to be the negative of g. Right, so I'm going to replace that with negative g. And so this is just multiplied by t squared. So now, let's just pull the minus sign out to the front. So we get this. So at this point, we have two equations consisting of 5 quantities. Right? It consists of V0, theta, g, r, and t. Remember, the whole goal is to figure out an equation which is r in terms of these 3 quantities. So we want to somehow eliminate time. So what we're going to do is we're going to combine these 2 equations into a single equation, eliminating time. And the way we're going to do that is we're going to take this equation and solve for time, plug that into the other equation. So, to do that, well, the first thing we're going to do is we're going to divide t on both sides of this equation. And certainly we're allowed to do that because time is not equal to 0. Right? We know time is not equal to 0 because certainly it's going to take some positive amount of time to go from this point to this point. Right? So we're allowed to divide t on both sides. So on the left-hand side, we have 0. On the right-hand side, we see that time cancels out. And when we do t squared divided by t, we're just going to be left with a t right here. So we're left with this. And next, to get rid of the fraction, let's just multiply 2 on both sides of this equation. If we do that, we get this. And then if we just algebraically solve for t, all we got to do is add gt to the other side and then divide g to the other side, and we get this. So we have taken this equation and solved for t. And so now we're going to plug that in to the other equation. And if we do that, we get this. Now notice we have v0 times v0. That gives us v0 squared. And actually, we have 2 sine theta cosine theta, which is actually a trig identity. If you recall, 2 sine theta cosine theta is the trig identity for sine of 2 theta. So that's just sine of 2 theta, right? This is all over the acceleration due to gravity g. So this is r in terms of these 3 quantities. So this is exactly the equation that we wanted. And so yeah, that's pretty much it for this video.